Hi guys. So I am home with my daughter's sick. She has a fever, so I'm stuck at home today. So we still are just reviewing for our quiz tomorrow. So basically, as all the information says on Classroom, I'm having you guys do this review worksheet first, and then afterwards work on the quiz review. If you feel like looking at this worksheet, you know how to do everything. You just want to use this as a reference for checking answers. Feel free, but I'm just going through what I would have done if I was in class. Okay, so I specifically made this worksheet to review the solving with exponential equations and function stuff that we did at the beginning of the unit. I still feel like that's the topic we probably need the most review with rather than the logarithm stuff that we just started. Um, so I'm just going to go through these problems. So let's see. So number one, it says a company promises to release a new smartphone model every month. Each model's battery life will be 4% longer than the previous models. The current model's battery life is 649 minutes. What will be the latest model's battery life 7 months from now? Okay, so this is an exponential situation because it's saying each model every month will be 4% longer than the previous models. That's a percent increase problem. Remember, the general form of an equation of an exponential function is y equals a times b to the x power. When we have percent increases or percent decreases, b, what we're multiplying by, the rate, changes a little bit. So in a percent increase problem, right, 4% longer, our formula is y equals a times 1 plus r to the x power, where r is our percent written as a decimal. So we can just substitute in all the values that we need. So the current model is 649 minutes. So we'd say y equals 649 times 1 plus r. Well, if it's 4% longer each time, we change that percent to a decimal. That'd be 0.04. And then x is the number of times it's happening. So if it's 7 months from now, to the 7th power. Okay, so that's what we can throw in our calculator. 649 parentheses 1 plus 0.04, close our parentheses, caret key 7. So we get 854.04. So we can say approximately 854 minutes. Okay. Let's look at two. Rubber bouncy balls drop from a height of 162 centimeters onto a hard flat floor. After each bounce, the ball returns to a height that is 20% less than the previous maximum height. So this is a percent decrease problem because each drop, it's losing 20%. Right? So now it's y equals a times 1 minus r to the x power. This is what will be the maximum height reached after the sixth bounce. Okay, so we'd say y equals initial height 162 times 1 minus r, well, 20% less each time, so 0.20 or zero point 0.2. And then it's happening 6 times, 6 bounces. So to the sixth power. Throw this in our calculator. 162 times 1 minus 0.2, caret key 6. So our new height is 42.47 centimeters. Okay. What else we got? Okay, so now it says solve each continuous one. So remember, if we look at 3, a savings account balance is compounded continuously. Compounded continuously is where we introduce that idea of E, the irrational number 2.718, where when things compound continuously, that means that they're approaching or they're being multiplied by e, where e, remember, that's 1 plus 1 over infinity raised to the infinity power, and that approaches 2.718, that approximate number. Okay, so it says if the interest rate is 3% per year and the current balance is 1677, what will be the balance 6 years from now? Okay, so this is a compounded continuously problem. This is that formula y equals p e to the rt power, right? We see that phrase compound continuously, we think PERT, P-E to the RT power. Okay, so we would say y equals, our principal, P is 1677 times E, you don't need to put parentheses there, and then to the RT power, so to the 0.03 times T, T is 6. Okay, And we could throw this in our calculator. 1677. Remember, E is in blue right underneath that pi symbol. Second E, caret key, parentheses, 0.03 times 6. So we get $2,007.73. Okay. Let's look at 4. For a period of time, E. coli bacteria in a culture grows exponentially if the continuous growth, okay, so continuous growth, key phrase that introduces E into our problem, is 3% per minute. Current population is 119 million. What will be the population 10 minutes from now? And continuous growth, y equals PE to the RT power. Initial amount, 119 million. So let's use 119 and then communicate that million piece in our answer. E to the 0.03 times 10 power. Okay. 119 E. Oops, sorry guys. Second E. Caret key, parenthesis, 0.03 times 10. Okay, so now there's a population in millions of bacteria. So we'd say approximately 160.63 million bacteria. Okay. All right, let's see what's on the back side. What else we got? So now this is what we did on Friday. Okay, I introduced how to solve exponential equations by changing the bases or using logarithms. Okay, so remember going back to a simple example, like maybe let's start with 6 right here. 2 to the 2r power equals 2 to the 6 power. Well, 2 to some power equals 2 to some power. You're going to get the same answer if your exponents are the same. Okay, so really all we need to do is say, well, let's make 2r equal 6. We can solve for r. R equals 3. Well, that makes sense, right? If we put in 3 for r, 2 times 3, that's 6. Now it's 2 to the 6 equals 2 to the 6. So remember what we did on Friday was we worked on changing the bases to get the same base with each of our powers, and that allowed us to set the exponents equal to each other. So now taking a step back and looking at 5, 6 to the 3m minus 3 power equals 36. Well, they're in different bases, so why don't we rewrite 36 as a power of 6? So 6 to the 3m minus 3 equals 6 squared. Now we have that same base, and we can set those exponents equal to each other. 3m minus 3 equals 2. Add over the 3, 3m equals 5, divide by 3, 5 over 3. Okay. Let's look at 7. Different bases. Unfortunately, it's not as simple as just saying make 216 be a base of 36, right? Written as a power, because 36 squared is significantly larger than 216. But if we know our powers, these could each be rewritten as the base 6, okay? Because 216 is 6 to the third power. So we could rewrite this as 6 to the third power all to the 3n plus 3 power equals, let's rewrite 36 as a base 6 squared. Well, then going back to what we did Friday, remember our laws of exponents, a power raised to a power, we could distribute because we multiply the exponents. Okay, so really we'd have 6 times 3n to the 9n, 3 times 3 plus 9 equals 6 squared. Now we have this rewritten with the same base for each of our powers, where we can set the exponents equal to each other and say 9n plus 9 equals 2, and solve. Subtract over the 9. 9n equals negative 7. Divide by 9. Negative 7 over 9. Okay. Same idea in 8. We'd love to just rewrite the 8 as a power of 4, but 4 squared is not 8, right? That's not something that can be done easily. So why don't we rewrite each of these down to a base of 2? Okay, because 8 is 2 to the third power raised to the 2x minus 1 power. And 4 is 2 squared raised to the 3x power. Distribute. So now we'd have 2 to the 6x minus 3 power equals 2 to the 6x power. Now we can set these equal to each other, the exponents. So you say 6x minus 3 equals 6x. Subtract the 6x over. So now we have negative 3 equals 0. Well, that's not true. There's no solution. There's no answer. That's fine. That just means there's no value we could put in for x. That would make 8 to the 2x minus 1 power equals 4 to the 3x power. Doesn't exist. Okay. But then we talked at the end of class on Friday about how sometimes we can't solve these by rewriting the bases because they're not magically set up where we could write these as nice powers, okay, with the same base. So let's look at 9. Okay, so now it says negative 10 times 12 to the negative r equals negative 3. Well, first things first, let's get this to just be a power without this negative 10 hanging out in front. So let's divide both sides by negative 10 to get this just to be a power equals a number. So now we'd have 12 to the negative r power equals, negative divided by negative makes a positive. That'd be really 0.3 or 3 over 10. So now there is no way that we could easily rewrite 12 to a base of 0.3. Just can't happen with powers, right? So this is where we talked about how using this main idea of the unit that logarithms and exponentials are inverses of each other, we can get this exponent out of the negative r by taking the log base of whatever the base of the exponent is to both sides. So log base 12 of 12 to the negative r power equals log base 12 of 0.3. Log base 12 of 12, again, you don't need to write this down, but this is saying 12 to what power equals 12 to the negative r power. Well, what's going in this spot? Well, it would be negative r is our output. It undoes the 12 to the negative r power. It just rewrites this as just negative r. Okay, so the log goes away on the left side. We're left with just negative r equals, and then log base 12 of 0.3, that's just a number. Okay, we could evaluate that. That's saying 12 to what power equals 0.3. Well, that's not something we know off the top of our head, but we could use a calculator to do that. Remember, to evaluate this, we always put in our calculator as log of 0.3 over log of 12. Okay, we'd say log 0.3, close our parentheses, divided by log of 12. So we get negative 0.485 approximately. Well, now this is set up to solve, right? We just gotta get rid of the negative that's in front of r, divide both sides by negative 1, flip the sign. We're gonna use that approximation symbol since we did approximate here, 0.485. Okay, let's try another one. So power to a power, or we have a power equals a number here. Let's first get rid of the 2 in front, right? Divide both sides by 2. Now we'd have 7 to the x plus 7 power equals, let's see, 78 divided by 2, that's 39. Again, going back to what we said, there is no easy, nice way with whole numbers to rewrite 7 to the x plus 7 equals 39 using both base 7 or any base. Okay, so this is where we need to use logarithms to get that exponent, or get the x out of the exponent. So we're going to use the base that's with the exponent of 7. So we can say log base 7 of 7 to the x plus 7 power equals log base 7 of 39. Log base 7 of 7 goes away. We're left with just x plus 7 equals, this is a number, right? To find this in our calculator, we do log of 39 divided by log of 7. Log 39 divided by log 7 we get 1.883. Keep solving. Subtract over the 7. X is approximately 1.183. Okay. Hopefully this is helpful as a guide of how to go back through the exponential problems. So now you can work on the quiz review. Anything you don't finish from your quiz review will be homework, and then I also posted a key to that on Classroom with the post. Okay. All right. I'll see you guys tomorrow.